Space exploration is advancing rapidly with new rocket and probe designs, pushing the limits of technology. In this video, we'll tour the most advanced upcoming spacecraft, both crewed systems and autonomous probes. We'll explain what makes each one cutting edge, who's building it, and the materials and innovations involved. Our tour will range from SpaceX's giant Starship to Europe's Ariane 6, from China's Tianwen planetary probes to NASA's new deep space robots. Quantum knowledge here, bringing you some of the latest and greatest spaceflight inventions and news. If you enjoy this video, please like, subscribe, and hit that notification bell for more quantum knowledge. Let's jump in. SpaceX's Starship is a two-stage super heavy launch system designed for fully reusable flight. It uses a novel stainless steel alloy, modified 304L, for its entire structure, which is stronger at cryogenic temperatures and can withstand re-entry heat better than aluminum. The first stage, Super Heavy, packs 33 methane liquid oxygen Raptor engines, 24 at sea level, 9 vacuum optimized, while the upper Starship stage uses 6 Raptor engines. Starship's sheer size and reusability make it advanced. After booster separation, it returns to land vertically, and SpaceX claims it can relaunch in as little as 1 hour. The vehicle's heat shield also uses transpiration cooling, ejecting water through its ceramic tiles to carry away heat. Key features. SpaceX, Elon Musk, builds Starship with large welded steel rings. Its engineering challenges include cryogenic propellant management, landing precision, and developing the new high-strength steel alloy. Starship's innovations: massive stainless structure, integrated thrust structure, and full reusability, aim to drastically cut launch cost and enable Mars missions. NASA's Orion is a deep space crew capsule built for Artemis lunar missions. Lockheed Martin leads its construction with an aluminum-lithium alloy primary pressure vessel and an ablative heat shield. Orion's heat shield is 5 meters across, 16.5 feet, one of the largest ever made, and uses AVCoat, the ceramic-infused epoxy used on Apollo. Innovatively, the AVCoat is cast into approximately 200 pre-shaped blocks bonded to a carbon fiber skin, speeding assembly versus manual pouring. On top sits a solid-fueled launch abort tower for emergency escape, and on the bottom, it lands by parachutes. The companion European service module, built by Airbus ESA, provides propulsion and power. It carries 33 hydrogen-oxygen thrusters and 4 large solar wings, 7 meters each, for power. The ESM is armored with Kevlar panels to defend against micrometeoroids. Why it's advanced? Orion is human-rated for 4 astronauts and deep space re-entry, surviving lunar return temperatures. Its engineering hurdles include the huge heat shield manufacturing, life support integration, and safety systems. Thanks to AVCoat and rugged structure, Orion is built to survive multiple re-entries with refurbishment. Blue Origin's New Glenn is a next-generation heavy-lift rocket, not yet flown, named after astronaut John Glenn. It's designed to be partially reusable. The 23-foot diameter first stage, 7 meters across, will return to land on a ship. The first stage is powered by 7 Blue Origin BE-4 engines, liquid oxygen methane, and the second stage by 2 BE-3U engines, liquid oxygen liquid hydrogen. In planned upgrades, New Glenn 9x4, the first stage will use 9 BE-4 engines and the second stage 4 BE-3U engines, boosting payload to approximately 70 metric tons to low Earth orbit. Its fairing is 7 meters wide, twice the volume of smaller rockets. Materials and design. Tanks and structure likely use aluminum alloys and carbon composites. Booster P-120C solid boosters use carbon fiber cases in related Vega C program. The liquid oxygen liquid hydrogen upper stage is optimized for efficiency, and New Glenn will carry up to 13 tons to geostationary transfer orbit, or 45 tons to low Earth orbit. Challenges include designing the reusable thermal protection and ensuring 25-plus reuses for the booster. New Glenn's innovations include staging for human rating, built-in safety redundancy, and a large payload fairing, all aimed at reducing launch costs. Blue Origin, founded by Jeff Bezos, builds New Glenn with U.S. supply chains. Europe's new heavy rocket, Ariane 6, led by Ariane Group for ESA, replaces the Ariane 5. It comes in two versions, Ariane 62 with 2 solid boosters and Ariane 64 with 4. Core stage, 5.4 meters diameter, 32 meters tall, powered by a Vulcan 2.1 hydrogen-oxygen engine, 138 metric ton thrust. The Vulcan's nozzle uses laser-welded cooling channels for robustness. The stage's propellant tanks use a new lighter aluminum-lithium alloy, lighter than Ariane 5's. Boosters, P120C solid fuel boosters, 13.5 meters length, 3.4 meters diameter. Each burn approximately 142 tons of propellant for approximately 4,500 kN thrust. Upper stage, a cryogenic stage with a restartable Vinci engine, can reignite up to 4 times, and a built-in auxiliary power unit to pressurize tanks. The fairing is a one-piece carbon fiber composite shell, 5.4 meters wide, that encloses payloads. Innovation. Ariane 6 focuses on modularity and cost reduction. It uses larger solid boosters shared with Europe's Vega C and modern manufacturing, laser welding, one-piece fairings, to streamline production. Built by Ariane Group, Airbus, Safran joint venture, Ariane 6's engineering challenges include scaling up the new engine and integrating cryogenic systems. Its modern engines and lighter tanks improve performance over Ariane 5. China's Tianwen series, by China National Space Administration, China Aerospace Science and Technology Corporation, are interplanetary exploration spacecraft. Tianwen-1, Mars. Launched July 2020 on a Long March 5 rocket. This 5-ton Mars probe, one of the heaviest Mars missions, carried an orbiter, lander, and the Zhurong rover. After orbiting Mars for months, the lander delivered Zhurong to Utopia Planitia, May 2021, China's first Mars landing. Zhurong is solar-powered with 6 scientific instruments, cameras, spectrometer, radar, weather station, and collected soil samples. The orbiter also carries cameras, radar, magnetometers, and particle detectors to study Mars's environment. Tianwen-2, Asteroid-Comet Sample Return. Scheduled for launch approximately May 2025, this probe, launching on Long March 3B, uses large solar panels and an ion propulsion system. It will rendezvous with near-Earth asteroid Kamo-Oalewa, 2016 HO3, collect samples, and return them to Earth in 2027. Then it will swing by and orbit a main belt comet, 311P Pan-STARRS, with spectrometers, cameras, radar, magnetometer, and dust gas analyzers on board. A re-entry capsule will deliver the asteroid samples to Earth. Innovation. These probes use advanced autonomy for cruise and landing, new propulsion, ion thrusters on Tianwen-2, and large precision guidance, inserting into deep space orbit. They are built by the China Aerospace Science and Technology Corporation with international components, e.g., some instruments from European Space Agency or Russia. China's roadmap continues with Tianwen-3, Mars sample return, and Tianwen-4, Jupiter probe with Europa Callisto elements. Beyond crewed ships, cutting-edge robotic probes push space exploration farther. For example, NASA Dragonfly, Titan rotorcraft. Launching approximately 2027, arrive 2034, Dragonfly will fly a multi-rotor drone on Saturn's moon Titan. It's the first time NASA will fly an aircraft-like vehicle on another world. With its radioisotope, RTG power, and onboard autonomy, Dragonfly will take off repeatedly, traveling up to approximately 115 kilometers per hop across Titan's thick nitrogen atmosphere. Each flight, about every 16 Earth days, it will land and use drills and spectrometers to analyze organic-rich soils. This lets it explore dozens of sites, dunes, crater, etc., on Titan, far beyond a single landing zone. The engineering innovation is flying under 1.5 G Titan gravity, with 4 times denser air, using carbon fiber rotors and autonomous navigation. NASA Europa. Clipper, Jupiter Moon Orbiter. Set to launch. October 2024. Europa Clipper will orbit Jupiter and fly by the ice-covered moon Europa some 50 times. It's NASA's largest planetary spacecraft to date, with 2 huge solar panel wings, 100-plus feet span, to generate power 5 astronomical units from the sun. Its payload, 9 instruments, includes ice-penetrating radar, spectrometers, and cameras to probe Europa's subsurface ocean. Advanced features include its radiation-hardened electronics for intense Jupiter environment, and precision flyby navigation. By repeatedly skimming the surface at approximately 25 kilometers altitude, Clipper will map the ice shell and search for plumes, helping assess Europa's habitability. NASA Psyche asteroid mission. Launched 2022, Psyche is en route to a metal asteroid, 16 Psyche, in the main belt. Uniquely, it will use solar electric propulsion, Hall effect ion thrusters, the first use of such engines beyond lunar distance. Large solar panels power xenon ion thrusters, blue glowing plasma, to efficiently cruise to the asteroid. Psyche's chassis, by Maxar, and thrusters, Jet Propulsion Laboratory, showcase advanced deep space propulsion for future missions. Futuristic concept, laser light sails. Scientists are also studying exotic propulsion. For example, the Breakthrough Starshot Initiative, California Institute of Technology, Harvard, proposes tiny gram-scale probes riding on ultra-thin light sails, pushed by ground-based gigawatt lasers. In principle, these nanocrafts could reach approximately 20% light speed and get to Alpha Centauri in approximately 20 years. While still experimental, labs at California Institute of Technology have begun testing sail materials and dynamics under laser pressure. Project status, on hold, but research continues. NASA Interstellar Probe. Concept. NASA has studied missions to the edge of the heliosphere. A future interstellar probe might use advanced ion nuclear propulsion to travel 1,000-plus astronomical units from the Sun, sampling the interstellar medium. While no mission is approved yet, studies, vision mission, solar gravitational lens concepts, etc., highlight new power propulsion needs, radioisotope or fission power, beamed sails, fusion, etc., for an interstellar precursor. Each of these autonomous systems requires cutting-edge materials, e.g. composite airframes, radiation-shielded electronics, and software for decision-making millions of miles from Earth. Together, they represent humanity's push into new frontiers, from Titan's surface to interstellar space. From SpaceX's stainless steel Starship and NASA's Artemis Orion to Blue Origin's New Glenn, Ariane 6, and China's Tianwen exploration probes, today's spacecraft blend innovative materials, powerful engines, and advanced autonomy. In crewed vehicles like Orion and Starship, engineers overcome heat and safety challenges with new alloys and thermal protection system designs. In rockets like New Glenn and Ariane 6, they optimize engines and structures, aluminum lithium tanks, composite fairings, for performance. And in robotic probes like Dragonfly and Europa Clipper, they design instruments and power systems, solar sails, radioisotope thermoelectric generators, ion drives, to operate in extreme environments. This cutting-edge spacecraft, built by SpaceX, NASA, European Space Agency, China National Space Administration, and others, will soon launch us into a new era of space exploration. If you watched until the end of the video, you are amazing. Like and subscribe for more quantum knowledge.